me get started by sharing my screen here. So what we're going over today is, so last week we did a little bit of, during my presentation last week, we talked a little bit about SQLite, and during that presentation, it seemed like a good idea to maybe pick the next presentation to do a little bit of a deeper dive to, especially for those of you that aren't as comfortable with SQLite as you'd like to be. I'm just going to kind of go through some strategies and some of the ways that I think about SQLite databases when we run into a SQLite database or run into an application on mobile or even on macOS or Windows. Most applications are using SQLite in some way, so it's really good to get yourself familiarized with different strategies and techniques to tackle and sort of manually review SQLite databases. So I've got my notes here. These are markdown notes. We're going to make them available to everybody so that you have a copy of it. And I'm going to use this as sort of my roadmap to go through the presentation. So one of the first things that I wanted to bring up, just everybody I think knows this, but just wanted to cover it. But a lot of times when applications are using SQLite to store data, they don't always identify themselves as SQLite. So you're not always going to see like database.sqlite is the file on a file system, whether it's on mobile or in Windows. A lot of times they don't even have an extension. So when you're looking at data, it's not always immediately obvious whether a file is a SQLite database or not. But I can tell you in my experience, especially if you start digging into the guts of Google Chrome and Chromium-based browsers and Google Drive, you'll just see tons and tons of files that are SQLite databases, but they're not necessarily labeled that way just by looking at it in the file system. So there's a couple of techniques to kind of quickly find SQLite files and to tell if they exist. One is if you're using a hex editor like Xways or WinHex or FTK Imager, something that lets you kind of actually see the raw binary data of a file. I mean, you can just simply look for the file signature that just says SQLite format 3. You see this, it's in the file signature of the file. It makes it immediately obvious that it's a SQLite database. Most tools, like most file processing tools, will usually have file signature verification processes. So you can also run that process across a batch of files in Xways or Ncase or something, and it will read these magic bytes in the file header, and basically the software itself will identify it for you as some kind of database or SQLite database. But sometimes you just don't need to do that. If you don't want to wait several hours for that process to run, okay, just if you think a file might be SQLite, just open it up in some kind of forensic hex viewer or hex editor, and just look at the file signature in ASCII. It's very simple. If you don't happen to have, the luxury of having a forensic suite or a hex editor with a nice UI that you can look at things, there's also a couple of commands here. I don't use Windows as much anymore unless I need to, so I do a lot of stuff on Mac now. But here's a couple of commands that you can run that will basically just output, the first 64 bytes of the file in this nice hexadecimal format, so that you can see the hex data and then see the ASCII representation of that data. And basically, it's the same as looking at this file in a hex editor. You're just looking at the first 64 bytes, and it's just outputting it nicely for you. So a couple of very simple, easy commands to run to give you that view to quickly identify, okay, is this file SQLite or not before you try opening it with something. And if you want to go the extra mile, you could write yourself a script, in Python or something that will do this in mass, where you just run a Python script, point it at a directory, and have it scan every single file in a directory or a folder structure and look for anything that has a SQLite file header, and then basically put that into a text report or something. So if you're trying to build your own set of utilities and tools, this is a really good thing to do. You could also write bash scripts that include this stuff too as well. There's lots of ways to kind of do this to try to help you find any possible SQLite files. So my tool of choice for SQLite deep dives and in SQLite review is DB Browser for SQLite. I think most of you, if you've done any kind of SQLite stuff, you're probably familiar with this tool. But it's honestly, in terms of forensics, it's one of the best free tools that you could possibly get your hands on. It's basically just a database management and a SQLite management system where it's free and cross-platform, works on Mac OS, works on Windows. Like I said, it's free. You don't have to sign up for anything to download it. You just go get yourself a copy. and they've been maintaining it for years, so it's a well-maintained product. It gives you that visual GUI so that you can actually visually look through and browse through a SQLite database without having to write a bunch of Python code or anything like that. And finally, it lets you actually, it's a database. It's not a, so to be clear, this isn't a forensics tool. It is a SQLite utility. So it lets you query and run queries and run and execute results and export results. So that means you have to be very careful about, if you're using it as a forensic tool, be very careful about making changes to the database. Okay, it does have, when you're using it, it does have a committing transaction system. So if you do happen to make changes, you can revert those changes in the software. It doesn't automatically commit those changes for you. So you have to, if you accidentally make a change to the database, you have to actually tell it to write those changes before it actually does. So you do have like an escape hatch there in case you modify the database in some way on accident. And so just to kind of provide an example of this, I can, what I'm going to demonstrate here is, I'm going to share my screen in a different way here. So what you're seeing here, this is one of our free tools on the website. It's called Monolith Notes. And basically it's a system where you can create basic, simple cases, and you can go into Monolith Notes and create notes, right? So we have notes here, we have text and images, things like that. Well, the reason I'm showing you this, obviously it's our tool, but also I'm showing you this because we use SQLite to store these notes and track these cases. So if I'm doing a forensic investigation and I kind of want to see more metadata about these notes, or I want to see like, more info than what I can see here in the application, or if I'm on, let's say I'm examining a computer that has Monolith Notes installed, and maybe I don't have the Monolith Notes application, so I can't see the data set in its, or native format. Well, then I need to go figure out where this data is stored. And then, I find out, oh, it's stored in a database, a SQLite file. Well, great. So I can then open that file and start digging into it. So what I'll do is I actually have a copy of one of our Monolith Notes databases, and I'm going to open it up in SQLite browser just to kind of give you a review of some of the features in DB browser. Give me just a second while I open it. Okay, so I have DB browser for SQLite opened, and what I've done is I've opened up a copy of the database that we use for our Monolith Notes application. And so just a couple of things to point out here. You have multiple panes here, but the first thing that you're seeing is what we call the database structure, which is, it's just telling you all the different tables in the database. It's telling you the scheme, what we call the schema, so you can see like what kind of data is being stored in each table. And this is usually a good place to start. If you're looking at a database for the first time, like if it's a chat database or web browser database or a log database, any kind of database, a good place to start is just to review this table schemas and understand kind of, okay, usually most applications will give pretty good semantically reasoned names to the tables, so you can kind of clearly understand what these things are in terms of like the column headers and the table names. And then you just kind of get a feel for like, okay, where do I think, knowing that this is a note-taking application, like where do I think data is going to be stored, and how do I think it's going to be stored in a database like this? So we have our first table here called case notes, which seems like a pretty good candidate to store the actual note data for this application. So we can go to browse data here, and then we have our table selector here. We can select case notes, and then we just see, okay, cool. So we're seeing some content here, right? So we're seeing, okay, it looks like text content, and more specifically, if you pay attention, this is not raw content. This is HTML or XML, but it's XML formatted content, but specifically this is at HTML, because we can see paragraph tags, we can see bolded tags, things like that. So we know this is we can surmise this is a rich text editor that uses HTML for its text editing. And now we can see, okay, here is the text for this. And then from here, we have other utilities where we can apply filters. We have filters right here. So you can, if you're searching for certain data sets, you can search for specific words like here. And basically you can apply these different filters. This is sort of like using a UI to build a query. We also have other utilities here where you can export entire tables, you can insert records, you can do lots of stuff here. But the really nice feature here is that we can execute SQL queries. And in here we can say like a simple select all from case notes. So I can do a very simple query here just to pull everything from that case notes table. And then from here, you can go on and do all kinds of stuff. So there's tons of features in this, but this is sort of the basic use case that I have, where looking at the table structure here, browsing through the different tables here to see different types of data, and then using the query execution system to run and build queries for what I'm, for whatever data set I'm trying to compile or review. And this is a situation where you don't just have to run queries just to select and output a bunch of rows. You can also do more complex queries to actually run searches. Look for keywords. You can do complex joins or complex SQL queries just to do any kind of thing that you want. That maybe things that you would normally do in your analysis platform through UI, you could just do it. If you know SQL well enough, you can just start writing your own SQL queries to do it instead. So let me switch back over to my notes here. So now that we have an idea of like how we now have this tool to use so we can start looking at databases and start examining them. The first thing that you should, if you're not familiar with SQLite, or if you're not as strong with it as sort of reverse engineering it as much as you should or feel like you should be, the first thing to kind of keep in mind is you've got to, keep the mental model in your head that SQLite is a relational database. So what that means is you're going to have tables which are like, you can think of as individual spreadsheets of data. And then those tables are going to have columns that map to each other. So a good example of this would be in our Monolith notes database, we know that the application has a list of cases and a list of notes. And then when you navigate to a case, you see a list of notes that are a part of that case. So what that means is that for a SQLite database, there is going to be two tables that relate to each other over a common value. So you're going to have a case notes table and a cases table. And for the application to know that only certain notes are a part of a specific case, that means the case notes have to have a column or some way of knowing, hey, this case note record is associated with this case. And the way it's usually done is by using something like an ID value, like a case ID value, where the notes table will have a column called case ID, and the value in each row for that case ID is going to map to the ID of a case record. So once we have that, we can then combine those two tables together using that common case ID column. And then what you get is a list of cases and a list of, with a designator for what case, a list of case notes and a column that tells you which case those notes are a part of. And that's how we kind of reverse engineer and put these things together. But learning how relations work in SQLite databases is probably the number one thing that you really need to learn and understand in order to do any kind of deep dive in SQLite. This is the most critical piece. There's lots. SQLite and SQL, like structured query language, is a very, very deep concept on its own. But for your case, for your purposes, for doing forensics or examination of SQLite, understanding the relational aspect of databases and how to use those relations when building queries is probably the most fundamental thing you need to understand. Because this is how you're going to put all this data together and start understanding how to extract what we call semantic information from these databases. So I have another example here with chats. So very common situation you might run into is you come across some third-party funky chat system and you don't have a parser for it. So you need to kind of build your own parsing system to extract those messages. Well, most chat applications usually follow a very similar structure. Usually there is a table for chats, which identify conversations, because most chat applications, the way they work is they establish a communication channel between the owner of the chat application and anybody else they're talking to, which could be, and that communication channel could just be between them and one other person, or it could be between them and multiple other people. So most chat applications, they organize their data with a chats table that just identifies all the different grouped conversations that a person may have. And then what they have is a table called messages, and the table just stores the raw messages. So if you're looking at the iOS messaging app, each individual message that you see rendered in a bubble in that iOS app corresponds to a record in a messages table. And then basically, so you have your chats table that identifies all the different people you have conversations with, and then you have messages that corresponds to all the specific messages that you have generated inside the application itself across all chats. And then between the two, there's usually, like we described, there's going to be some kind of chat ID column. Some apps will put the chat ID column right there in the messages table, but some apps will have some kind of what we call a junction table, which is sometimes it's called chat message join, sometimes it's called chat join, message join, something like that, where basically all it will have is usually 3 columns. It'll just have something like its own ID column for its own records. It'll have a chat ID column and a message ID column. And all this is doing is just creating a map saying this message ID goes to this chat ID. And then whenever queries are run and built, you then basically, when you write a query, you then have, select all from messages, left join chat, left join chat message join on chat message join dot, message ID, dot whatever. And basically you have a third table that gets joined in order to put everything together. And this is done because of things like many-to-many relationships and more efficient storing of data and that sort of thing. So this is the sort of, when you're looking at most databases and trying to reverse engineer, this is the sort of pattern you need to look for is you have some data set you're trying to extract and trying to understand if that data set is a subset of some other data record, and then put those two together, figure out what the common column ID is, and then determine if there is a junction table between them that connects the two data sets together. And then once you have that, you can then write, design queries to kind of put all that data together and then get an output that's what I'm calling this sort of semantic model of data, which is you're trying to get an output of data that makes sense to you as a human being. Okay, so this is something you're not going to, if you've never done this before, you're not going to suddenly know how to do this just from me explaining it. This is one of those things that you're going to have to practice out at. You're going to have to get DB browser, load some databases in, and start playing around with this and doing it, basically drill it a couple hundred times, and then you'll eventually build that skill set around SQLite and SQL and understand how these relations work and how to put this data together. Okay, the next big thing in SQLite, especially when we're trying to reverse engineer these SQLite databases, when we're investigating different applications, trying to get forensic data out of them, is we really need to understand timestamps in SQLite and how, in the various ways in which these timestamps are put into a database. So what I have here is a list of common timestamp formats that databases use, especially SQLite. And this is all stuff, just so that you guys know, when developers make an application, like when we make our Monolith Notes application, as engineers, we get to decide how we want to store these timestamps. There's nothing in SQLite that dictates a timestamp has to be in a particular format. We can store them however we want, and then the application will then parse that timestamp in whatever way we decide to parse it. So what that means is that you can have timestamps literally stored in any possible way you can think of, but because engineers are lazy, we tend to just stick with the most common formats because they're known. We all understand them. We don't have to think of something new out of the box. So I've got a table here that generally lists the most common types of formats, starting with Unix time, which is just the number of seconds since 1970. That's a pretty common one that you'll see a lot. This was sort of one of the initial timestamp formats that we've used in computing. Now, eventually we came up with milliseconds because if we want better resolution, if we have there's certain applications that have intense amounts of logging and things like that, you want better resolution so that you can differentiate, the order of which events happened. So having millisecond resolution on a Unix timestamp can be helpful. And a lot of places, even though they don't need that resolution, they still just default to that timestamp just because it's a standard. So in the way to tell the difference between these is just look for the length of the string and just look for, you can, when you look at these timestamps long enough, you can kind of understand from there, just by visually looking at them, which version of timestamp they are. Then you also have microseconds. This one's used a little less often, but you'll still see it. Again, it's just another level of precision on the timestamp where you get even more resolution in terms of ordering of events. But they're all pretty much the same thing. You're just calculating different numbers, different values, and the magnitude is just different when you're doing the conversion. You also have a what's called an ISO 8601 string, which is just a text value that represents the time, that it's in this specific format. So this is easy to tell. You can usually read it right out of the database, understand exactly what the time is. And it's basically easy to tell it's ISO by this big T that's used between the date and the time, and then usually a time zone identifier, which almost always is a large Z. So this is the most common way that you'll see ISO timestamps in databases. Um, and this one's nice if you run into it because then you don't have to do any parsing of the timestamp. You can just read it as a human being right out of the database, which makes it nice to see. And then you have some lesser used ones. So this Julian day, this is stuff that you'll see sometimes in like Windows, things like that. Sometimes you'll get custom epochs like Windows file time that just use like they just, Microsoft is Microsoft, so they like to just do random things for no apparent reason. And one of those things was they invented their own timestamps and their own epochs and things like that. So that's always fun when you're trying to parse this stuff. But luckily, you're not really going to see these very often in SQLite databases. You're going to see this stuff more at the operating system level with operating system logs or file systems, things like that. And then lastly, I wanted to point this out that a few years ago, Apple started using nanoseconds. They started using their own epoch and their own format, which is basically nanoseconds since 2001-ish. Okay, so again, similar to Microsoft, for whatever reason, Apple decided to invent their own time format. And so this is really important when you're looking at iOS messages and text message databases, is that they started using nanoseconds, but you'll sometimes see over time, like with Apple, when they made this change, they didn't go back and update the timestamps for previous messages. So if you had a phone with an SMS DB like this, and it had text messages from before the iOS update that started including nanoseconds, you now had a table where there was a mixture of Unix milliseconds and this new nanosecond format. So that could be really, really bizarre when you're trying to write a query in the SMS DB from iOS, where you're just trying to get a simple list of, okay, show me all the messages where it shows me the chat ID, the chat session name, the message, the send time, the to and the from, incoming, outgoing. And now you have to account for this difference in the timestamp format because it could be different across multiple messages. So this is probably outside of the understanding the relational aspect or characteristic of databases and SQLite specifically. The next thing is really understanding timestamps and understanding how they're stored, how they're designating time zones. Most timestamps in databases are going to be stored in UTC, but it's something that you need to pay attention to and make sure that you're acknowledging when you're writing a query, just understanding, okay, what time zone is it stored in and how am I outputting that time zone in our data set? If I'm writing a query, how am I designating the time zone? Okay. And just down here in my notes, I just have examples of different queries that are writing to parse out these different types of timestamps. So you can see here, like, this is why I also want to bring your attention to this, because you can see this is a fairly complex system you have to account for when you're trying to parse out these timestamps, because each of these different types of timestamps requires a different parsing method. And you can see they just go from fairly simple to complex, but there's all this stuff that we're doing in SQLite to get it to render what we consider a human readable timestamp. So we can actually output something that makes sense to us when we're parsing this stuff. So I've got a bunch of examples here that you guys can use on the notes and play around with. So this is one of the things where after this presentation, get a copy of these notes and get DB browser for SQLite. If you have some evidence you're working on, extract the SMS DB from a phone that you're working on, from iOS, from an Apple device you're working on, load it up in the DB browser and start playing with some of these queries. Start running them, start building your own queries to see if you can create a list of your own chat messages that you can pull off of the phone. The other reason I say this too is, don't assume that my queries here are correct either. These are queries I put together, but I could have made a mistake. There could be a bug in some of these queries. There could be one of these calculations are off or something. So feel free to test these and verify them, validate them, and send me an email and call me a jerk for getting these queries wrong. I would love to see that, and tell me how the query should be written. I think that's going to be a huge value add to you guys and help you out a lot with kind of getting used to this sort of way of investigating SQLite databases.
Hey, Matt.
Yeah.
We got a couple of requests. Could you make this a little bit bigger?
Yep.
Thank you.
I can. Let me find the Zoom here. Let me just try this. There we go. Here, I'll close this chat. Uh, make this a little bit bigger. There we go. All right. Is that better? And you guys will get a copy of this too. So this isn't the only time you're going to see it.
Yep, I think that'll do it. Thank you.
Perfect. Okay. So now we're going to kind of get into a bit of a fun part that I think you guys are really going to like. So over the years, and if anybody has been to webinars I've done in the past, you may remember last year I did a vibe coding webinar where I was trying to show how you can use AI to help write Python scripts and stuff like that. And it failed miserably. It worked great for me when I tested it outside of the webinar, and then when I got in the webinar, it just kind of fell flat on its face when I was trying to get it to write a fairly simple Python script. Since then, AI in terms of writing code and doing these sorts of things has tremendously improved. And what's great about SQLite and SQL specifically is because of what SQLite is. SQLite is a semantic language that we use to write queries. And what that means is that large language models like OpenAI or ChatGPT or Claude or whatever are very, very good at parsing and writing SQL queries. Because if it's nicely, because what these LLMs are, they're natural language processors. So they just go really well with writing SQL queries. So what you can actually do is there's some strategies here I'm going to show you where you can use AI to help you design and help you parse out these databases and write queries that you want. So the first thing, and again, we're going to use DB browser for SQLite, and I'm going to demonstrate the process for doing this. So what I'm going to do is I'm going to um, open up a simulated text message database um, in DB browser. I'm going to walk you through a couple of steps here. Give me just a second. So I want to make sure you guys can see all this. Okay. So what you're seeing here is that I know the text is going to be really, really tiny, but don't worry about that. That's not really important. I've got a text message database from iOS loaded into DB browser. This is actually from my personal phone, but I've gone in and cleared out all of the I've replaced all the message data with stuff that are not real messages. So I don't leak click any messages I have or anything like that. But basically what we want to do is if we want AI to help us with this, one of the things I'm going to do is I want to provide the AI context of the database that we're working with. And one of the ways I can do that is I can just export and go to File here, DB browser, select the export option, and then select Database to SQL file. And what this is going to let me do is under options here, I've got all the tables selected already. Under options, instead of export everything, I just want to export the schema only. And what this is going to do, it's going to export a SQL file that basically has a plain text description of the structure of this database. So I'll go ahead and save this. And I'm going to save this to here. Is that right? Yeah, that's right. Okay. So I've saved a copy of it, and I'll go back to my note editor here. And I am going to view this. So here, I saved it here. So I'll open this up. And what you'll see now is this is basically a bunch of SQL queries that will create tables. But what it's doing is it's basically outputting the structure of all these tables that make up this database in plain text. Okay. So now I have this nice plain text file that describes exactly what the database looks like. And what I can do is I can switch to something like ChatGPT, which I will switch to now. And actually, I'm going to move this over. Okay, so I have ChatGPT here. And what I'm going to do is I'm going to upload a copy of this SQL file. And once it has that SQL file, again, it has the structure of our text message database. I'm going to ask it, can you write a simple query? Can you write, I'll just say query. can you write a SQL query that will output a simple list of messages that includes the chat name, sender name, message, and timestamp. So I'm giving it a pretty simple prompt. And what I want it to do is look at this file and then basically help me write a query that's going to export the type of data that I'm looking for. Now, I haven't done this specifically with ChatGPT, so I'm hoping this goes well. But it's going to look at that file, start reading through it, and then build a query for us that we can try to run. And here it's going through, giving us some options and saying, hey, if this is an iPhone, it's actually building something like this, where it's saying, hey, if you're using an iPhone SMS database, it's giving me, this stuff here. And it's saying, hey, important. Notice what it's doing. It's telling me, hey, important iOS timestamps. They're in nanoseconds, and their epoch is since January 1st, 2001. And so it's giving us some information, but the important thing is this right here, is it's giving us this SQL query. And let me see if I don't know if there's a zoom on ChatGPT, but okay, yeah, it looks like there is a little bit. So we now have this query that I'm going to copy. I don't know if it's going to work or not. I'm hoping it does, but we're about to find out live to see if this query actually works. I'll switch back over to my DB browser. And then I've copied that query. I'm going to head over to my execute SQL. And then I'm going to paste in that query and I'm going to run it. And let's see if it actually works. And it did. So now I have a query here that's really simple. And it looks like the chat name was wrong, because I don't see any kind of chat name here. But we are getting, we're getting sender information, we're getting message content, and we're getting a timestamp. And all I did, and that's all I asked it for. I didn't ask it for anything else. I just said, hey, put together a fairly simple, query that just outputs a few properties of these messages for me. And so from here, what you can start doing is you can start asking the ChatGPT to refine the query and I can say, okay, this is great, but the chat name column is empty. Can you review and refine the query? And so it's going to go and basically re-review its own work, look at the queries it wrote, and then see if it can get a better idea as to how to fix the query to get us a little bit more information. And it looks like it's thinking for a while. Oh, sorry, you guys can't see this. Hang on. So I've got it in sort of, long analysis mode. So it's kind of going through and verifying everything. We'll see how long it takes. And in the meantime, I can show you while that's running, I'll switch back over to my note editor. Now I'm using this in this presentation as a note-taking system, but really what this is actually a code editing platform that has AI built right into it. So what I can do is I can do the same thing I just did in ChatGPT, but instead I can do it right here inside of my code editor or note editor. And this is also, it's called Cursor. This is a paid system, so I'm paying a subscription to use their platform. But I can do things like I can open up an agent chat window and I can basically point the agent at this SQL file and say, and it just asks the same thing I asked ChatGPT. And I'll ask it, can you write a SQL file that contains a query that will output a simple list of messages from this SMS DB that includes chat name, message content, sender, and timestamp with formatting. Formatting and time zone ID. So what I'm doing now is basically giving a similar prompt that I gave to ChatGPT, but the difference here is this is a code editor, so it's actually going to do the same thing, but this time it's going to create a file for me and actually build a query that's just going to be in its own self-contained file. When I do this stuff in ChatGPT, you actually get the output in a UI that you then have to copy that content and then paste it somewhere else. And so here it's going through this sort of long chain of reasoning to review. And it looks like it's reviewing some other stuff that I had previously, but we'll see what it gives me. So now it's writing out the file and it's created it for us. And then it's giving us, it's about to give us a summary of what it's done. So I know it seems like the agent's taking a while to do this, but if you think about it, if you're trying to do this yourself, this might take a minute or two for the AI to do it, but it might have taken you 30 minutes to potentially do it. So what I'm gonna do is click keep here, and then I can open up this, and it's basically showing me a query that it has created. And I can then copy this query, and we're gonna run this. I'm gonna pop this into our DB browser and see what kind of result we get. Keep in mind, I'm not even reviewing what it is. I'm just simply copying and pasting it and see what kind of output we get. So now we're getting same situation, but now we're getting like formatted human readable time zone. This time the query included a time zone ID column, so we know what time zone we're in. We've got sender information, so we can see people's phone numbers. And then here we have message content that outputs it. We're still not getting that chat session name, but that's probably just because iOS doesn't have a chat session name. It's probably just based on the sender ID. There's probably some more investigation work we would need to do there. But the point is, we're basically doing this. The only thing we really have to do is verify that the timestamps we're getting, that it's generating are accurate. Verify that, okay, is it getting the right timestamps? Is it formatting them correctly? Is it getting the right time zone? All that stuff. And then going through and maybe reviewing the structure of the query to make sure, validating that we're getting the right content that we expect to get in our output. And then if I switch back to ChatGPT, I can see the output here, and it's given us a very similar output, which again, I'll copy this one, switch back over to DB browser and see what that looks like in DB browser. So it's a much longer query because I asked to do some extra stuff. Let's see what we get. So now what we've got is we do have a chat name now, and it's just because of the way that iOS databases work, the iOS database doesn't actually have its own contacts table, like something that identifies a person that you're communicating with. It just has the phone number of the person you're communicating with. So we would have to sort of resolve who this person is. We would then have to join it with, we'd have to get the contacts database that the phone uses and then connect it through the actual phone number. And then use that to resolve an actual person that we're communicating with. And this is what your tools like Appsy and SQLite are doing. They're taking these different data sets and like combining them together in the application to show you something that's usable. But basically, as you can see now, like with this stuff, I didn't write this query. I didn't do anything. I just gave, the important thing is I gave the context to the AI where it understands what the database looks like. And then I gave it very specific instructions on what to do. Hey, write a query, give me a query that will give me a list of records that contains this information. And then with that database context, it can review it and then work on a query. It's not going to be 100% every time, but it's going to be, these AIs are good enough now where they're going to be very, very close. And at that point, it's just a matter of validating the output that it gave you, making sure that it's accurate, making sure that, you're getting correct information, and then also just doing your own investigation to make sure you're getting, hey, am I getting as much information out of this database as possible? What else is here? And that's part of your job as the analyst, is to look through the table structure and think about the application in terms of how it works and what data you actually see in the native application, and then trying to map that to the data that's in the SQLite database and figuring out how do I extract that information so that we can use it forensically. And this is not just important for things like, most forensic tools now, they do a lot of this for you. You guys obviously don't have a problem reviewing text messages from Apple devices or Android, like SQLite and Axiom. They do that great. Lots of other tools do that great already. But there could be scenarios where maybe it is parsing that stuff, but you want to validate something. You find a message that's really important to your case, a strong piece of evidence, and you want to somehow validate. You want to go in and validate and make sure that message is accurate, and make sure the forensic tool is showing you something that's correct. Or you might think, hey, I know there's some extra metadata around this message because I can see it in the application, but my forensic tool of choice isn't displaying that information to me. It's not parsing it. So you may want to go into a deep dive like this and investigate and figure out where that extra metadata lives, like where in the database is it, so you can extract it. And this is where your knowledge of the database and examining it and going through it and reverse engineering it, plus giving that database context to the AI. If you know there's some data in there, you just don't know how it's stored or where it's at, well, give the database the structure, give the AI the structure of that database, and then ask the AI questions about it. Like, hey, I see in the app that this database is related to that there's this piece of metadata that says this. Can you look at the database structure and tell me where that data might be located? And then it will tell you, like, yeah, it's probably located here. Check this table or this table, and then it will help you analyze and go through the SQL data that you're working with. So that kind of wraps up my presentation for today. Hopefully, this was helpful. We'll move into the sort of Q&A portion. Again, you guys will get copies of these notes and everything. But I just wanted to end on this AI thing, which I think is going to be very, very useful for most of you. But I'll pause there and see if we have any Q&A to go through.
All right. Don't see any new Q&A yet. If you guys missed it at the beginning, if you want to come on microphone and ask a question, go ahead and raise your hand and I'll give you permissions to talk and we'll bring you up on stage and you can ask your question directly with us. I did have somebody in the chat ask to see how to export the schema again.
Okay, sure. Yeah, let me walk through that really quick. Let me share my screen again. Okay, so we've got the database loaded into DB browser. And in order to export the schema, you go to File, Export, and then select Database to SQL file. Now you can export it as CSV or JSON, but I find SQL is better for AI context. You database to SQL file, select all the tables. They're already selected by default. And the important thing is you want to export the schema only. So this is really important because if you're working with evidence, if you're working on evidence, you do not want to export the data because if you do everything, it'll include the data also. And so you'll end up inadvertently uploading somebody's chat message data to OpenAI or whatever. So be very careful. And also, it's not necessary. The AI can do just fine with just the schema. So you export the schema, click save, and then it will ask you, where do you want to save it? And you save it, wherever makes sense. And now you have a SQL file that has the structure of the entire. And what's important, it's not just the structure of the database, it's a natural language version of the structure of the database so that the AI knows how to read it and can understand what it is.
All right, cool. We don't have any raised hand questions yet, but somebody in the chat is asking, when will we get recordings of these workshops? I can field that one.
Yeah.
So we usually send, if you registered for the live event, you'll usually get the recording a day or two after that, and then we're posting them publicly on our YouTube channel about 30 days after the live event. So we actually just published our first workshop Wednesday this morning. So if you head over to our YouTube channel, there's a playlist called webinars. Head there for ones in the past. Otherwise, if you keep signing up, we'll send you that recording a couple of days after we do the live session. Ooh, we have our first raised hand from Edward. Allowed to talk. All right, Zoom should be asking you to access your microphone, and then if you unmute, you should be able to come on and ask your question, Edward. Maybe I can ask him to unmute. Ask to unmute. Hello, Edward. Nope, maybe.
It was unmuted for a second there.
I think that was accidental.
Okay.
Well, in that case, let me disable your talking. We had another one come in from chat from Barry. It says, I'm new to analysis. Is this a beginner level webinar or are there others that are offered? If there are others, can they be found on YouTube as well?
I would say this is probably, I would say this one's a little bit above beginner, just because we're talking about a lot of context that if you're just getting started in forensics, you may not have. Like, and if you haven't worked with if you haven't done a lot of examinations and understand the context for which forensic tools are showing you data. There might be some context you don't understand, but I would say if you're new to this, I would say this is an essential thing that you should learn. I think it's a great place to start your career is to start digging into SQLite databases and learning how to run SQL queries and learning how databases work. Because to me, I think in forensics, I think it's just an absolutely necessary skill that we should all have, because it's just important for when you need to do things outside of the sort of forensic tools that we have available.
All right, we've got another question that came in through the chat here from John. What is the best AI model for coding in your experience if we only wanted to purchase one?
So that's a good question. Honestly, I think there's some, if you look into it, there's some coding specific AI models. I mean, I think I'm using most of the time. My code editor is actually set to auto, so it kind of just decides for me what the best one is. But I think I've been flipping between Opus 4.6 and then Cursor has its own code editing model called Composer. And then you also have GPT Codex as well. So what I would recommend actually is if you're looking for a code writing system, I would actually look into just using Cursor because the way Cursor works is you pay a subscription to Cursor and then they have access to different models that you can use. So you're not actually purchasing access to a model, you're just purchasing access to Cursor, and then Cursor through their coding tool gives you access to different AI models that you can use for coding. And you can even set it to auto, where it will kind of pick for you based on what you're asking, or you can pick a specific coding model to use. And then it even has some other options where like there's like something called max mode where it like I forget exactly what it does, but it gives you even more like um, you know, gives the AI a little bit more open range to do things, but then it becomes more expensive. It uses more tokens, that sort of thing. So that's why if you're talking about coding, I would just get something like Cursor or maybe Copilot and VS Code, and then use those things that are built right into the code editor.
All right, I think that might be it for. Oh, I spoke too soon. We got another question that came in through the chat from Malaysia. Apologies if that's not how you pronounce your name, Malaysia. Is there a website or where do you research app table details, like to know the setup for Snapchat? Um, or I guess where could you go to get like the schema for the databases if you were trying to reverse
Yeah.
engineer them?
So the way I do it, there's nowhere I go. I usually have, I don't do as much forensic work anymore as I used to, but when I did, I would always have a few phones, or in the case of mobile forensics, I would always have a couple of dummy phones that I would do tests on and forensic examinations on just to understand how things worked. And basically, if I want to know how an app stores its data, I'll install the application on usually a phone that I have root access to, that I can do a full file system extraction. And then I'll just export the guts of the application and then start digging around to find how it stores data. So like I know with Snapchat as an example, I haven't looked at it in years, but the last time I did, Snapchat doesn't store a database, a SQLite database on the phone. It actually would store a text file. I think it would store its ephemeral message inside of a JSON file on the device. So you didn't have like a database it was stored in. And that's another system where it's like, okay, now you have to learn what JSON is and how to parse out JSON data. But that's how I always do it because there's so many apps out there and they change all the time. They engineer the apps to do different things over time. So even if we had something that wrote up even we had an app or a website that described the schema of all these different apps. I mean, unless we're constantly like month after month after month reviewing these apps all over again, the schemas change and that data would get outdated very quickly. So my strategy that I would recommend is basically download the app on a device that you have full access to, and then just export the guts of that app off the phone and start investigating it yourself.